Hi everyone. So for week 4, I've decided to make a screencast video for the submission for this week. So just on the importance of sleep. I'll just go through each of the questions. I've highlighted the important areas to include in your responses, as well as some of the important parts of each question that you should be looking at when answering the question. So I'll just start from the beginning and make sure you're comparing these responses to your own. For question number 1, this is a task that you need to do, which would have produced different results for each of you. I haven't done this myself, but in reading what the task was, I realized that it probably wouldn't go down too well if I did it. Mainly because, for some reason, I don't dream. Or, I do dream, but I don't remember my dreams. So, and I haven't really gone too much into it and tried to figure out why. So maybe one of you could do that and let me know. But, yeah, number 1, you guys should have gone through each question and identified a number of things. For example, what time you went to bed, how long you slept for, how you felt before and after going to bed, whether or not you woke up during the night, and whether or not you remember your dreams, and just things like that. Question number 2, you were asked to watch a video and answer a question. We had to identify the results of the research and what it told us about the human sleep cycle. So there are 2 things to comment on here, just the results and the human sleep cycle, making sure that you comment on both. So this research highlighted the fact that people rely on a biological clock that follows a circadian rhythm. This was evident when all environmental cues were removed. It was also noted that most people's biological clocks run on an approximate 25-hour schedule, with the most extreme case recorded having a cycle of approximately 50 hours. Number 3, Dominic is a healthy newborn baby. Cassie is a healthy 30-year-old adult. And Arthur is a healthy 82-year-old adult. How would you expect their sleep patterns to differ? Refer to the total sleep time and proportions of time spent in REM and non-REM sleep. So, again, it's asking you to comment on 2 things. Total sleep time and the proportions of time spent in REM and non-REM sleep for each of the 3 individuals. So Dominic would be expected to sleep around 16 hours. So that's a newborn and an infant, okay? We know that that's how long they sleep for, on average. Of which he would spend approximately 50% of the time in REM sleep. Sleep onset can occur at any time of the day or night, with no regular sleep or waking periods. So we know that babies just sleep whenever. They wake up during the night and they sleep again. And onset can be quite irregular. Dominic's sleep duration may also be irregular, with sleep episodes lasting anywhere from 30 minutes to 4 hours per episode. Dominic's sleep onset will occur through REM sleep as opposed to non-REM stage 1, and each episode will consist of only 1 or 2 sleep cycles, hence the shorter duration. So they won't have the 4 sleep cycles that adults would have, just because they're sleeping at different times throughout the day and on a lot more occasions than adults. Cassie is expected to sleep for approximately 8 hours per night, and around 20 to 25% of this will be in REM sleep. Cassie's sleep should be relatively consolidated, however, she may experience brief and minor awakenings during the night, which usually occur during the transition between REM and non-REM sleep. Arthur is expected to sleep for approximately 6 hours, and around 20% of this time will be spent in REM sleep. In comparison to Cassie, Arthur will become sleepy earlier in the evening and will wake earlier in the morning. He will also spend the majority of his non-REM sleep in stage 2 and far less in deep sleep, stages 3 and 4, as he did when he was younger. So we know that as you go older, the amount of time you spend in REM sleep decreases. Okay, so it's gone from 50% as a baby or an infant to 20 to 25 as an adult, and once you go over the age of, I guess, 60 or so, when you reach the elderly, it'll go down to around 20%, as well as the number of hours that you sleep during the night. So number 4, explain why sleep is considered to be an altered state of consciousness. Sleep is considered an altered state of consciousness due to the differences in awareness and physiological responses. Characteristics include reductions in awareness, time orientation, self-control, conscious control over thoughts, and ability to perform tasks or attend to sensory stimuli. So, when we're in a state of consciousness, okay, not an altered state of consciousness, just a regular state of consciousness, we show all of these characteristics without the reductions, obviously. So when we're in an altered state of consciousness, okay, all it is just a reduction in these characteristics. So when referring to the stages of consciousness, always think about the characteristics, and then just see what the question's asking you. So why is it considered an altered state of consciousness? Okay, because there are reductions in these characteristics. Alright, easy. Number 5, Imogen, who is 20 years old, was sleeping soundly and had been asleep for approximately 2 hours when there was a loud noise outside her bedroom window. How likely is it that Imogen would wake up instantly and easily? Justify your response with reference to REM and non-REM sleep cycles. Okay, given that it is early in the night and that each sleep cycle lasts for approximately 90 minutes, we can assume that Imogen would be in her second sleep cycle for the evening, most probably towards the end of stage 2. So, if each cycle goes for 90 minutes, okay, she's gone through one cycle, that leaves 30 minutes of the 2 hours that she was sleeping for. So in 30 minutes, okay, she'd pass stage 1 of non-REM sleep and would probably be in stage 2. That's why that's there. During stage 2 non-REM sleep, Imogen would be receptive to external stimuli such as loud noise outside her bedroom window and would therefore be woken fairly easily. So she would be receptive to external stimuli due to being in the early stages of sleep. This means that she's more likely to wake up from things that would happen in the background, so in the external, in her external environment. Okay, 'cause she's only in stage 2 of non-REM sleep, so it's still early in the sleep. If, however, Imogen had progressed further into her second cycle, for example, stages 3 or 4 of non-REM sleep, then she would be in a deep sleep and would most likely not register the loud noise and would not wake up easily or instantly. For example, if she had been asleep for around 3.5 hours, okay, or 3 to 3.5 hours, then we can say that, okay, 90 minutes is for one cycle. If we add another 90 minutes to that, okay, we'd probably have around 3 hours. So towards the end of the second cycle, we'd probably be in a deep sleep or in stages 3 or 4. And we can say then when we're in a deep sleep, okay, we're more likely not register any loud noises. Okay, we wouldn't be receptive to any external stimuli. It's very hard to wake us up. And I'm a bit like that as well. Once I'm asleep, okay, once I'm in my deep sleep, you could probably hold a party in my bedroom, I wouldn't wake up. And for those of you that came to the seminar at DCV, we had a yoga we had a yoga class towards the end of the seminar, and I may have fallen asleep. And within 20 minutes, I was in a deep sleep and snoring my brains out. Okay, number 6. This referred to pages, some questions in your textbook. So you guys can look directly at these questions and revise your own answers. So you can do this yourself. I'll go down to question 7. Distinguish between the terms endogenous and Zeitgebers. So distinguish meaning almost comparing the two. Endogenous means that circadian rhythms are controlled by internal biological processes, while Zeitgebers are external cues that can influence cyclical changes in circadian rhythms such as food, light, and temperature. So endogenous are controlled by internal biological processes, and Zeitgebers are external cues that can influence changes in circadian rhythms such as food, light, and temperature. Describe 2 arguments that support the evolutionary theory of sleep. So 2 arguments and the evolutionary theory. I've highlighted these 2 bits. Small animals do not need to consume much food to meet their requirements, so therefore they need fewer waking hours to eat and can spend more time sleeping. Small animals that sleep longer do so because sleep protects them from harm, because when they are asleep they are not moving and are therefore less likely to attract attention from predators. Provide two differences between the sleep patterns of an adolescent and an adult. Adolescents require 9 hours of sleep compared to adults who require 7 to 8 hours. And adolescents experience a natural sleep-wake cycle that prevents them from feeling tired until late in the evening, whereas adults do not experience this shift. So 2 differences between the sleep patterns of an adolescent and an adult. It's important that you're not identifying something, for example, this would not give you, one of these points would not give you full marks. Okay, so this is just one difference between the 2, and then this would be a second difference. Okay, it's not identifying something that a characteristics of an adolescent sleep and an adult, but 2, and making 2 comparisons. Number 10, provide 2 differences between the sleep patterns of a newborn and an elderly person. Newborns sleep for longer periods than elderly people, 16 hours compared to 6 to 7 hours. Okay, that's easy, we know that. Elderly people spend 30% more time in non-REM sleep than newborns. Okay, well done. Another thing you can point out is the amount of REM sleep. So we know that a newborn would spend approximately 50% of the time in REM sleep and 50% of the time in non-REM sleep, and we know that the elderly spend about 20% of the time in REM sleep and the majority of the time in non-REM sleep. There we go, yeah, that last point there. 11. Explain how light influences the human sleep-wake cycle with reference to biological structures and processes that regulate the cycle, and why sleepiness is highest at night and lowest in the day. So, this is where we have to refer to melatonin. So, melatonin is a sleep hormone that is secreted from the pineal gland. Its release is regulated by the suprachiasmatic nucleus, causing sleepiness when it is dark. When we are exposed to light, a signal from the eye's retina is transmitted to the suprachiasmatic nucleus, and the secretion of melatonin ceases, therefore preventing sleepiness. What does the SCN stand for? Explain its role in sleep. So the SCN stands for the suprachiasmatic nucleus, located in the hypothalamus of the brain. This is an internal body clock that governs the human sleep-wake cycle through the release of melatonin, so it's the hormone that causes sleepiness, and cortisol, the hormone that causes alertness. So cortisol is released during the day to keep us alert and awake, I guess. 13. Recordings from an electromyograph, EMG, can distinguish between rapid eye movement, REM sleep, and non-rapid eye movement, non-REM sleep, because there is A. Never any movement of the muscles in REM sleep, unlike non-REM. Okay, so that would be the answer there. Okay, so we know that the electromyograph measures the muscles. Okay, so using the DARE, okay, detects, amplifies, records the electrical activity of the muscles. So during REM sleep, okay, there's never any movement of the muscles, unlike non-REM sleep. And when we're in a deep sleep, there's very little movement compared to when you're in non-REM sleep. So to answer this question correctly, you need to remember that an EMG takes its recordings from the larger skeletal muscles, such as the thighs, where during REM sleep these muscles are limp. It is only the smaller muscles around the eyes, as measured by the EOG, fingers and toes, that occasionally twitch during REM. It is for this reason that REM sleep is known as paradoxical sleep. The body externally appears calm, while internally the brain and body are active. Describe the EEG recordings of a person as they progress through the different stages of sleep. Think about the acronym BADD, which is the pattern of brainwave activity, and you'll see why. So just as we are about to go off to sleep, when we are in a deeply relaxed state, beta waves shift to a pattern of alpha waves, which have a medium to high frequency and a low to medium amplitude. As we drift into the first stages of sleep, non-REM sleep stage 1, alpha waves are still present. As we move into non-REM sleep stage 2, theta waves become highly prevalent and are characterized by low to medium frequency and medium to high amplitude. During stage 2, sleep spindles, which are short bursts of high frequency, and K complexes, which are short bursts of high amplitude, are also experienced. So we know that these two, we know that the sleep spindles and the K complexes are always occurring in stage 2 of non-REM sleep. During non-REM stage 3, delta waves occur, which have high amplitude and low frequency, and then by non-REM stage 4 sleep, delta brainwaves mainly occur. Towards the end of the sleep cycle, when we reach REM sleep, which occurs after the 4 stages of non-REM, beta-like waves occur that have low amplitude and high frequency. So, at the beginning we see beta waves, okay, a shift from beta waves to alpha waves, and we know that the beta waves are primarily high frequency, low amplitude, and as you move down, from beta to alpha to theta to delta, okay, the frequency becomes progressively less and the amplitude progressively increases. So that's where BADD comes in, okay? But then when you move into REM sleep, those beta-like waves occur once again, and with high frequency and low amplitude. So it's almost like you're adding another B at the end here. But then you wouldn't be able to say BADD. So explain how we dream in both REM and non-REM sleep. Question 15. So about 20% of dreams occur during non-REM sleep, whereas 80% of dreams occur in REM sleep. When dreams occur during REM sleep, they are longer, clearer, and more detailed than when they occur in non-REM sleep. Okay, so that was the last question. That took me 20 minutes. Wow. I hope that helped everyone. I know there's a lot of highlighting there, but sometimes that's what you need to do. What I'd take out of this is, as you go question by question, and through, for example, this week's SAC, just really try and read the question carefully and try to identify what it's actually asking of you. Try not to miss out on any marks. See how many marks are allocated to each question, and really try and figure out what information you need to include in the question. Make sure you're only answering the question, not including any irrelevant information. Alright, good luck for those of you that haven't done the SAC yet. I'm sure you'll all do well. Thanks everybody. I'll see you around. Bye.